Today we are doing lesson 1.4, which is solving absolute value equations. Now the good news is most of what you're going to see today we've been seeing all week. All right, we're going to be solving equations. The beginning of these problems is where the new information is coming in, and the beginning of these problems are where most people mess up when they're doing a quiz or a test for me. So I want you to stay with me. I want you to take good notes. I want you to highlight when I tell you to highlight, and I'm going to make this as easy for you as possible. Before we even get into the lesson though, does anybody know what an absolute value is? For example, if I were to ask you the absolute value of 5, what would you tell me? 5. Okay. What if I asked you for the absolute value of negative 100? What would you tell me? 100. 100. So what you're telling me is the absolute value of any number I could possibly throw at you is a positive number. Now let me explain why. I want you to imagine that I am the center of a number line. I am 0 in the center of a number line. My desk over there represents the number 5 on the number line. My podium over here represents negative 5. What distance am I? How many spaces am I from negative 5 on the number line? 5 spaces. So there's no such thing as negative direction, right? I'm 5 spaces away from negative 5. How many spaces am I away from positive 5 on the number line? 5. All right, so I'm 5 spaces away. So this is why the absolute value of any number that I could possibly give you is going to be a positive answer, because absolute value is the distance that a number is from 0 on a number line. So you can't ever have a negative distance. Now, does anybody remember what the absolute value symbol or the absolute value, well, I can't say that because I'll give you the answer. The absolute value symbol. If you're looking at a problem, how do you know you have an absolute value in the problem? It's 2 parallel lines. It's 2 bars. So when you get to your notes and you see the essential question, how can you solve an absolute value equation? Directly under that, it says steps to solving absolute value equations. And I want you to go ahead and I want you to put the symbol in your notes. So right underneath where it says absolute value, we're going to put a straight line, we're going to put an X, and then we're going to put the other straight line. The X simply represents any number that I possibly could throw in between those bars. So the absolute value symbol are those straight parallel lines. Now, there are 2 equations that must be written when we are doing. So there are 2 equations that must be written when we have an absolute value equation. So I want you to take your highlighter and I want you to highlight equation 1 and equation 2. I need it to stand out to you that you must be writing 2 equations when you are doing absolute value equations. So you don't have to highlight anything behind those words, but I want you to highlight equation 1 and equation 2. Because if you only write one equation, you're not going to get the right answer ever. All right? Now, here's how you write equation 1. Super simple. You're going to remove the absolute value symbol and then write what you see. So that's equation number 1. Equation number 2 is almost as simple, but you remove the absolute value symbol, so you drop those absolute value bars, and you change the sign of your answer. So this is how you write your 2 equations. Now notice the next sentence on your notes. It says always check for extraneous solutions. I need you to highlight that because up to this point, checking has been an option. It is no longer an option for absolute value problems because there is a chance that one of the answers you find or both of the answers you find do not actually go back into the original problem and make a true statement. So you must check. You must check. I'm not going to make you check on paper, but you can check in your mind. You can check on paper if that's better for you. And you say, well, then, Ms. Johnson, how are you going to know if I checked? Because if you leave an answer there that isn't actually an answer, I'll know you didn't check. So you've got to check your answers. All right? So let's move right into example number 1. It says solve the equation. Now, these are simple. You look inside the absolute value bars, all you have is a variable. So we're going to drop the absolute value bars. We're going to write what we see. So equation number 1 for letter A is x equals 10. That's your first answer. Now for the second equation, it says drop the absolute value bars and change the sign of the answer. So we're going to drop the absolute value bars and get x equals. What is the answer to this problem? We're on letter A. See, don't skip letter A because we don't have two answers yet. We haven't written two equations. But what's the answer to the original problem? Because we have to change the sign of the answer, so we have to know what the answer is. What is the answer to letter A? No, not the original problem. The original problem has a 10. So what is the answer to letter A? 10. So we have to change the sign of the 10, and it becomes a what? A negative 10. And that is my second equation. Now, these equations already have x isolated, so we're done with these equations. But you have x equals 10 and x equals negative 10. Now, let's plug that into the problem and let's check it. What is the absolute value of 10? 10. Does 10 equal 10?
Yes.
Yep. Plug in negative 10. What's the absolute value of negative 10? 10. Does that make a true statement?
Yes.
Then we keep both of our answers and we move on. Go ahead and write the two equations for letter B. The first equation for letter B, if we simply drop the absolute value bars and write what we see, is x equals 25. And Emma, what is the second equation for letter B? We drop the bars and we change the sign of the answer, so x equals negative 25. Now let's check them. What is the absolute value of 25? Everybody, what's the absolute value of 25?
25.
Does 25 equal 25?
Yes.
Good, we keep it. What's the absolute value of negative 25?
25.
Does 25 equal 25?
Yes.
Then we keep it. All right, now look at letter C. We have the absolute value of x equals negative 6. What's the answer to this problem?
No solution.
No, I mean in the original problem, what is the answer that they've given us? They've given us negative 6, but I want you to think back to what we've said already today multiple times. The answer to any absolute value problem is always going to be what kind of a number? Positive. So is there any possible way that the absolute value of a number is going to come out to be a negative 6? So the final answer here is no solution. We do not have to write two equations. We don't want to write two equations. That's a waste of our time. The answer is no solution. So I want you to highlight the sentence that you see above C. Absolute values equal to negative numbers have no solution. Because I want you looking for it. When I give you that quiz on Monday or I give you that test next Wednesday, I want you looking. Absolute value problems. Is it equal to a negative number? Because that's easy. No solution. I'm finished. Go ahead and highlight letter C and negative 6. Anything that's going to make it stand out to you when you're studying this lesson for your quiz and your test. All right, now let's move on to letter D. Now we can see it's getting a little bit more complicated because now inside the absolute value bars we have an expression. All right, but still the rules are the same. For the first equation, we're going to drop the absolute value bars and write what we see. So x minus 1 equals what? 4. The second equation, we drop the bars. We still have x minus 1, but it equals negative 4 because we must change the sign of the answer. Now, because the left side of these equations are the same, we can a lot of times work the problems at the same time. This is a simple equation. How do we get x by itself in the first equation? We add 1, all right? And if you look at the second equation, it's the same thing. You're adding 1. So you can work these separately if you'd like, or you can work them at the same time to speed up the process. The negative 1 plus 1 cancels, so we're left with x equals what in the first equation? 5. 4 plus 1 is 5. And in the second equation, we have x equals, careful, negative 3. Now, we got to check them. So go back to the original problem. This is important. Always go back to the original problem, not the equation you wrote, because if you wrote the wrong equation, it's going to work when it actually might not. So go back to the original problem, 5 minus 1. What's 5 minus 1, everybody? Everybody, what's 5 minus 1?
4.
4. All right, we're going to do some elementary speed drills today. What is the absolute value of 4? Does 4 equal 4? Keep it. Negative 3 minus 1. When you plug negative 3 in, what's negative 3 minus 1?
Negative 4.
Negative 4. And everyone, what's the absolute value of negative 4?
4.
Does 4 equal 4?
Yes.
then we keep it. All right, do letter E. Set up your two equations and then wait for me to confirm before you solve. That's right. For letter E, the first equation is 2x plus 12 equals 4x. You simply drop the absolute value bars and write what you see. Jack, what do you think the second equation is?
2x plus 12 will be -4x.
There you go. Good. Drop the bars. Change the sign of the answer. So 2x plus 12 equals -4x. All right, now, this is not a simple equation. This is a multi-step equation. So we've got to think through, don't call me after midnight. What's going to be the first step to solving this equation? If we think through, don't call me after midnight. Move the variable. There's no distributive property. There's no like terms to combine. But look, you have a variable on both sides of the equation. So we've got to move the variable. Cameron, which variable are we going to move this time?
2x.
Good. We can't move the 4x because that would clear everything off of the right side. So we are going to move the 2x. How do we move the 2x? Subtract 2x from both sides. And that's going to work in both equations, so we can work both equations again at the same time. The 2x minus 2x's are canceling, and we have 12 equals. What's 4x minus 2x? All right, in the second equation, we have 12 equals. What's negative 4x minus 2x? Negative 6x. Good. So to solve the first equation, how do we finish it? Divide both sides by 2. So x equals 6. And in the second equation, how do we finish?
Divide by negative.
Good. Divide both sides by negative 6. So x equals negative, try again, negative 2. Good. All right, let's plug those answers in. Now, when we go back up here to 2x, what are they doing, or what are we doing with the 2 and the 6 that we plug in? We're multiplying. Remember, a number and a variable with nothing between them is multiplication. So what is 2 times 6? 12. What's 12 plus 12?
24.
And what's the absolute value of 24? 24. Now, on the right side, what are we doing with 4 and 6?
Divide by 4.
Hold on.
Oh, wait.
It's 4x, so what are we doing with the 4 and the 6 that we're going to plug in? We're multiplying. That's multiplication again. So what is 4 times 6? Does 24 equal 24? Then we're keeping that answer. All right, now we got to plug in that negative 2. What's 2 times negative 2?
Negative 4.
What's negative 4 plus 12?
Negative 8.
Is it negative 8?
Negative
It's positive 8.
positive.
And then on the right side, what's 4 times negative 2? Negative 8. Does 8 equal negative 8?
Yeah.
Careful. Does 8 equal negative 8? No. So we have just found an extraneous solution. So we are going to cross it out. You do not have to write out the words extraneous solution. I do not want you to erase it. I simply want you to cross it out, and I will know that you have discovered that that answer does not work. Do you see why you have to check, though? Because if you had not checked, you would have left both answers, and it would have been wrong. All right, go ahead and start working letter F. All right, what's the first equation on letter F? All right, does anyone want to stop her from writing an equation? Jordan.
No solution because it's negative 3.
There you go. Again, the absolute value of 3 plus x can never equal a negative number. So once again, we have a no solution. So don't write those two equations. Don't solve them. Because when you go plug them in, they're not going to work anyways, and you will have wasted a whole lot of time. Highlight the letter F and highlight the negative 3. So this is what I want you, when you're studying, you say, I don't know how to study math. Study this for absolute value equations. If the absolute value is equal to a negative number, there's nothing for you to do. Don't waste your time. It's no solution. Can't be done. Now, we're going to get a little bit more complicated on letter G. And look at the sentence above G and H. It says you must isolate the absolute value portion first. So I want everybody to highlight that. And I can see the test question in my head that every year people miss because they go straight to writing the two equations before the absolute value portion has been isolated. Now, I need to know, looking at letter G, someone tell me, what is the absolute value portion that needs to be isolated? When I say that, what am I talking about? What in letter G needs to be isolated before we start writing the equation? But you got to read it to me right. How do you read it? There you go. So I want everyone to highlight the absolute value of x minus 2. That's the piece or the portion of the problem that must be isolated before we can write our two equations. So look outside the bars. What is keeping that from being alone? Plus 5. So how are we going to move it to the other side? We're going to subtract it. Beautiful. We're going to subtract it from both sides. Now, keep those bars because we're not to that point yet. So we have the absolute value of x minus 2 equals 9 minus 5, which is 4. Now is the absolute value portion isolated?
Yes.
Now you can write your equations. If you write your equations too early, your answers will be wrong. So make sure you isolate the absolute value part first. Now what would my two equations be?
X minus 2 equals 4 and x minus 2 equals negative.
X minus 2 equals negative 4. All right, Odina, how do I solve for x in these problems? Good, I add the 2. This is a simple one-step equation, so I simply add 2, and it's going to work in both equations, so I can work them together. This cancels, and x equals 6. My negative 2 and 2 cancel, and x equals negative 2. Beautiful. Let's check them. 6 minus 2. What is 6 minus 2? Okay, everybody together. What's the absolute value of 4? 4, and what's 4 plus 5? Does 9 equal 9? Awesome. Now let's plug in negative 2. What's negative 2 minus 2?
Negative 4.
Negative 4. Jack, what is the absolute value of negative 4? Careful. The absolute value of negative 4 is 4. What is 4 plus 5? And does 9 equal 9? Perfect. So we keep both answers and we are finished. Now, letter H, grab your highlighter. I want you to highlight for me the absolute value portion that has to be isolated. Go ahead and highlight for me the absolute value portion that has to be highlighted because this one's a little even more complicated than letter G. All right, Asia, what is the absolute value portion that we must isolate first in letter H? The absolute value of 5x minus 1. Now, when you look outside those bars, how many numbers are keeping it from being alone? 2. So we've got 2 numbers to move. And listen to me, the order that we move them matters. This is still don't call me after midnight. So that is a minus 3. And what are they doing with that negative 2? What operation? You've got a negative 2 and a absolute value bar with nothing between them. That's multiplication, okay? That's multiplication. Now, I like where your head is because you're thinking, oh, well, actually the distributive property is first, okay? But here's what I need you to know. You cannot distribute over an absolute value bar. Here's how I want you to envision it. This is a wall, okay? The absolute value bars are a wall and you cannot get through them or over them, all right? Think about a real wall. You can't get through them or over them, all right? Parentheses are wimpy. You can get over them. You can distribute, but you cannot with an absolute value bar. So instead, we know that's a multiplication problem. They're trying to multiply negative 2 and the bar. So that's going to help us move it to the other side. Now, which one of those do we move first? The negative 3 or the negative 2? Based on don't call me after midnight. Are we supposed to add or subtract or multiply or divide first? Add or subtract. So we're moving the negative 3. And how are we moving it to the other side? We're going to add 3 to both sides. So we still have negative 2 times the absolute value of 5x minus 1. And it equals, what's negative 11 plus 3? Negative 8. All right, now how do we move the negative 2 to the other side? Divide both sides by negative 2. All right, the negative 2's cancel,
And I still have the absolute value of 5x minus 1, and it equals, what's negative 8 divided by negative 2? Positive 4. Now, did anybody think at the beginning of this problem, I should stop Miss Johnson and tell her there's no solution? Okay, here's the problem with that. All right, and this might be a note you need to add. You cannot make the call about no solution until the absolute value portion is isolated. Because look at the problem now. The absolute value of 5x minus 1 is equal to positive 4. So this problem can be worked out. So do not decide about no solution until the absolute value portion is isolated. Does that make sense to everyone? All right, because now we see that the absolute value is set equal to a positive number, so we can continue this problem. Jordan, what is the first equation that we would write now?
5x minus 1 equals 4.
Okay, and the second equation?
5x minus 1 equals negative 4.
Beautiful. All right, how do we solve this equation? What's the first step to solving it?
You'd add 1, right?
Okay, we add 1 to both sides. So 5x equals 5. We can do the same thing to the second equation. We add 1, the negative 1 and positive 1 cancel, and 5x equals negative 3. And then how do we finish this problem? Divide both sides by 5 in both equations. So x equals what in the first equation? 1, and x equals what in the second equation? Negative 3/5. You're like, Miss Johnson, it's a fraction. Do I have to check it? Yep, you do. All right, so let's check it. Back in the original problem, we're starting with 5 times 1. What is 5 times 1? 5. What's 5 minus 1? 4. What's the absolute value of 4? 4. Now we're in a dilemma. Do we multiply it by negative 2 or subtract the 3 first? Please excuse my dear Aunt Sally. This is order of operations. So you actually have to multiply first. In the order of operations, we multiply before we add or subtract. So what's 4 times negative 2? Negative 8 minus 3. Negative 8 minus 3. Negative 11. Does it equal negative 11? Yes, so we keep it, all right? 5 times, I know this is annoying, it's a fraction, but look what happens real quick. You got a 5 in the numerator and a 5 in the denominator, so they do what? They cancel. So you're simply left with negative 3. All right, negative 3 minus 1. Negative 4. What's the absolute value of negative 4? 4. 4 times negative 2? Negative 8, and negative 8 minus 3. Everyone, negative 8 minus 3. Negative 11. Does negative 11 equal negative 11? Then we keep both answers because both answers work. Last one. Now, what do we do when there's an absolute value bar on both sides of the equation? We do exactly what we've been doing. Here's the only thing you want to be careful of. Be sure to change the sign of both terms in the answer. So remember, for the second equation, we have to drop the bars and we have to change the sign of the answer. All right, we just have to make sure we change the sign of both terms or all the terms in the answer. So what's the first equation going to be? Let's do the simple one first. Asia, what's the first equation going to be? So we drop the bars, we get 2 plus x equals, we drop the bars, we get 2x plus 1. Drop the bars, write what you see. All right, what is the second equation going to be, though? We've got to drop the bars, and we have to change the sign of the answer. So, have we ever changed the left side of the problem? This entire lesson, have we ever changed the left side? Okay, so we're dropping the bars on the left and writing what we see, 2 plus x, which makes the right side our answer. So what do we have? What do we get when we change the signs? That's a what kind of 2x up there on the right side? So we've got to change it to a negative 2x. And that's what kind of a 1 up there on the right side? So we got to change it to a negative. So that's what I mean by changing the sign of both terms in the answer. Take your highlighter and highlight. Show yourself those sign changes. Now, how do we solve the first equation? We're going to work these separately since they are a little bit different. So how do I solve the first equation? What's my first step? Okay, we've got a variable on both sides. So I heard someone say that we're going to subtract 2x. I like it. We're moving the variable to the left. So we have 2. What is x minus 2x? It is an x, but you got to be careful. There's an understood 1 right there. So what's 1 minus 2? Negative 1x. All right, negative 1x, and it equals 1. All right, what would we do next? We're subtracting 2 from both sides of the equation. So negative 1x equals, what's 1 minus 2? And to finish this off, we do what? Divide both sides by negative 1. So x equals, what's negative 1 divided by negative 1? Positive 1. Awesome. All right, for the second equation, what are we doing first? Good. First thing we're going to do is we're going to add 2x to both sides because once again, we have a variable on both sides. So 2 plus, what's x plus 2x? 3x. Again, there's an understood 1 right there. And then it equals negative 1. What's the next step? Subtract 2. So we add or subtract. So 3x equals negative 3. And to finish this one off, divide by 3. So x equals negative 1. Beautiful job. All right, let's check it real quick. 2 plus 1 is what on the left side? The absolute value of 3 is 3. On the right side, what's 2 times 1? Plus 1, the absolute value of 3. Does 3 equal 3? Keep it. 2 minus 1 on the left side. What's 2 minus 1? 2 minus 1, everybody. 1. What's the absolute value of 1? 1. On the right side, what's 2 times negative 1? Negative 2. What's negative 2 plus 1? Negative 1. But what's the absolute value of negative 1? So does 1 equal 1? So we keep both answers. And that is lesson 1.4.